Okay, so today we're going to be talking about inequalities. Alright, inequalities are things like less than, greater than or equal to, less than or equal to. Also includes not equal to, even though we won't really use this symbol a lot. I'll go over these real quick just to make sure everybody's on board. Okay, this is our less than symbol. This is our greater than symbol. This one means less than or equal to. You can see it's kind of a mixture of a less than sign and an equals. Okay, this one's greater than or equal to. Okay, which means that the number could be larger or it could be the same. And then this one means not equal to. If you notice, this one is actually kind of a combination of less than and greater than, because not equal to means it could be smaller or it could be larger. So this is kind of like a less than or greater than sign. Alright, so now first, just for some real world examples of when inequalities might happen. Alright, so let's say you're at the amusement park and it said that you have to be at least 4 feet tall to ride the ride. Well, then that means that your height would have to be greater than or equal to 4. Okay? Because at least means it has to be 4 or more. Well, which symbol means equal to or more? Greater than or equal to. Okay, so that's one example of an inequality. Another example would be something like a weight limit, maybe on, some kind of trampoline or bouncy house or something. They might have a sign on it that says no more than 200 pounds to play. Well, that's an inequality. Okay, that would mean that your weight would have to be less than or equal to 200, because no more than means it could be the same or it could be less. Well, less than or equal to means it could be the same or it could be less. Okay, these are two generic examples of when you might come across inequalities in the real world. Anytime there's a range of things you can have instead of just one, you end up with inequalities. Alright, so the first thing we're going to have to do with inequalities is translate them. Okay, just like we translated sentences into equations, we also have to translate sentences into inequalities. Alright, so we've got twice a number increased by 4 is at least 10 more than the number. Okay, so I'm just going to go through here and show you how I would translate this. Okay, well, twice a number, since I don't know what number it is, that's my variable. So twice my variable would be 2x. Increased by is addition, 4. Okay, then I have is at least. At least means that much or more. So that's why I chose the greater than or equal to symbol. Okay, and then 10 more than that same number, which I still don't know, so that's my variable. So that's my equation, or my inequality, for that sentence. Alright, now the next sentence. The next sentence says 3 more than a number is less than twice the number. Okay, so I have 3 more than is plus a number. Again, I don't know what number that is. This time I'll use y. So 3 plus y is less than, so I'll use the less than symbol, twice the number. It's that same number, I still don't know it, so it's my variable, so 2y. So I have 3 plus y is less than 2y. So here all I've done is translated these sentences into inequalities. Alright, so now I'm going to give you a couple to see if you can translate. Alright, so the first one says twice a number is more than the sum of that number and 9. Okay, and the next one says the sum of twice a number and 5 is at most 3 less than the number. So, I'll give you a second, you can pause it, see if you can translate those into inequalities. Okay, so for the first one, again I have twice a number, so 2a is more than, so greater than, the sum of that number and 9. So 2a is greater than a plus 9. Alright, and the second sentence says the sum of twice a number, so 2b and 5, so the sum of 2b and 5 is at most. Okay, at most means it can't be bigger than. So it could be less than, or it could be equal to. And then it says 3 less than the number. So I have b minus 3. Because remember, less than is one of those turnaround words, so the 3 and the b have to switch places. So 3 less than the number is b minus 3. And there's my inequality. 2b plus 5 is less than or equal to b minus 3. Alright, so now we have to talk about how to solve these inequalities. Okay, here's an example. I have x minus 1 is greater than 4. Now let's just think about that for a second. We can probably figure this one out. Okay, if x minus 1 is bigger than 4, then what does x have to be? Okay, as long as x was bigger than 5, then when I subtracted 1, wouldn't I still have bigger than 4? Okay, so I can tell that the solution to this is x is greater than 5. Because as long as x is more than 5, then when I subtract 1, I'm still going to have more than 4. Right? Okay, so algebraically, how did we get that? Well, if this was an equation, how would you get rid of this minus 1? You would add 1. And if you add 1 to one side, you'd have to add 1 to the other side. Does it look like that same thing works for inequalities? That's because it does. Okay, the minus 1 and plus 1 cancel. You're left with just the x. 4 plus 1 is 5. bring down the sign. No difference, as if only difference of it being an equal sign or a greater than sign is that you bring down the sign that you start with. And that's our solution. Alright, so what about something like this? Again, let's just think about it. If 2 times some number has to be less than 10, then what would x have to be? Wouldn't x have to be less than 5? Because if I pick a number less than 5 and double it, then I would have less than 10. Okay, so I know that the solution is x is less than 5. Now let's see if algebraically it still would have worked again. Okay, how do you get rid of a times 2? By dividing by 2. The 2's would cancel, and I would be left with x is less than 5. Okay, so as you can see, these work almost identically to equations. You solve inequalities the same way you solve equations. And just instead of having an equal sign there, you have whatever inequality symbol that you started with. There is one exception. Okay? This inequality shows the exception. Okay? And I actually hate that I'm not going to get to let y'all figure this out on your own. But maybe we can still do it that way. You'll just have to be thinking. Alright, so let's solve this algebraically, just like we did on this problem up here. Okay, I have a times -4, so I'm going to divide by -4. And then the -4's cancel, and I get x is less than -2. Okay, but now let me check my solution. Okay, if I think x is less than -2, then any number less than -2 should work for this inequality. So how about -3? -3 is less than -2, so if I plug a -3 in here, it should be true. So -4 times -3 is less than 8. Well, that tells me that 12 is less than 8. And I'm pretty sure we all know that 12 is not less than 8. So where did we mess up? Well, we didn't mess up. It's just that one exception. Okay, I want you to think about for a second. Numbers, I want you to think about them on your number line. If you multiply or divide by a negative number, what does it do to all the numbers on the number line? It makes them change sides. Okay, it changes all the positives to negatives, all the negatives to positives. So it basically flips the number line backwards. Well, if you flip the number line backwards, what do you think it does to this inequality? Because less than means kind of pointing to the left, doesn't it? Well, if the number line gets flipped around and this is still pointing to the left, then which way is it really pointing now? It's actually pointing toward the bigger numbers. So our rule that we've figured out is that if you multiply or divide by a negative number, then you have to flip the inequality. Okay? So what that means is this is not the right symbol. So I'm going to erase it, and I'm going to flip it. See, it was a less than, but since I divided by a negative number, I flipped it, and now it's greater than. Okay? That's the only exception to inequalities being exactly like equations. Other than this one rule, solving inequalities exactly like solving equations. But you have to remember, at any point, if you multiply or divide by a negative number, you have to flip the inequality. Okay? So that means if that number you're moving from one side of the inequality to the other is a negative, and you're moving it by multiplication or division, that's when you flip the inequality. Alright, so now I'm going to give you a few inequalities to see if you can solve. Alright, so I'll give you just a second. You can pause it if you need to, and then we'll look at them together. Alright, so these should be pretty simple. On the first one, I have m minus 4, so I need to do plus 4 on both sides, and I get m is less than 7. On the next one, I have a plus 5 or a positive 5, so I need to subtract 5 from both sides, and I get c is less than or equal to negative 4. Okay, notice I didn't switch the sign on either one of these because I didn't multiply or divide by a negative number. Alright, the next one. This one looks a little different because I've got variables on both sides, but we know how to do equations with variables on both sides. We just get the variables on the same side. So I can subtract that a from both sides, and I get a is less than or equal to negative 4. And again, I didn't flip the sign because I didn't multiply or divide by a negative number. Alright, the next one, I have times negative 2, so I'm going to divide by negative 2 on both sides. The negative 2's cancel. I get d on the left. I get negative 3 on the right. And then I look up here at the sign, and since I divided by a negative number, I flip that sign over. So my answer there is d is greater than negative 3. Alright, next one, I have times 5, so I divide by 5. So I get t on the left, negative 1 on the right. This time, there was a negative number over here, but I didn't divide by a negative number. So I'm going to keep this sign the same. I flipped this sign over because I divided by a negative number. Over here I didn't flip the sign because I didn't divide by a negative number. Okay. And then the last one. I just have divided by negative 6, so I'm going to do times negative 6 on both sides. The negative 6's cancel. I get positive 42 on the left, f on the right, and since I multiplied by a negative number, I flip that sign over and end up with 42 is less than f. Alright, so that's pretty straightforward. Solving inequalities. Alright, there's one more thing we have to do with inequalities, and that's graph them. Okay, so let's start by thinking of this inequality. We have x is less than 3. So I'm going to start by putting points on numbers that would be solutions to this inequality. So in other words, numbers that are less than 3. Alright, well, 0 is less than 3. 1's less than 3. Negative 2 is less than 3. 2 is less than 3. Negative 1, negative 3, negative 4. All of those integers are less than 3. Is that it, though? No, of course not. What about 2.5? 1.2, 1.8, 0.3, negative 0.7, and all these decimals that are in between those integers. And everything less than on the left of negative 4 as well. So really, what we're saying is it's a line going to the left, because all of these points are less than 3. Okay? So really the only question is, where does this line start? Because I can't just start it here, because what is that, 2.5? Isn't there a number between 2.5 and 3 that's still less than 3? Well, what if I started at 2.9? Well, what about 2.99? Or what about 2.999? You can see how that would go on forever. You can't ever actually get the largest number that's less than 3. Okay, so the way that we notate that is with an open point around the 3. It's just a circle that's not colored in. Now what that means is that the line starts at the 3 but does not include the 3. So it includes everything to the left of the 3 but does not include the 3. Okay, so an open point does not include the number. A closed point does include the number. Okay, so if I had colored this in, it would mean that the 3 was included. I left it open because x cannot be equal to 3, only less than. Okay, so you can see that the open point is for the signs less than and greater than. The closed point is for the less than or equal to and greater than or equal to. Okay, so now our steps. These are very simple steps. Number 1, you circle the number. See, I could have went straight to number 3, circled it. Step 2, you either fill in the circle or not. How do you know whether to fill it in? Well, look at this right here. Right? If it can be equal to, it's a closed point. If it cannot be equal to, it gets an open point. And then, step 3, draw your line, or draw your arrow. Okay? So, the only thing you have to do there is decide which way your arrow's going. You can do this a couple different ways. One way is to find a solution. If I've got my circle on 3, and I find any solution, it'll tell me which way the arrow goes. Since I know 0 is less than 3, then my arrow goes toward the 0. Okay, so that's pretty simple. The other way to do it is just think about, this says x is less than 3. Well, where are the numbers that are less than on the graph? To the left. So less than goes to the left, if you're looking at it from the perspective of the variable. Okay, so you can find a solution, or you can look at, okay, are my numbers bigger than 3 or are they smaller than 3? And draw your arrow from there. Alright, so let's see if y'all can do some of these. Alright, I'll give you a second and then we'll do them together. Alright, so this first one, x is greater than or equal to negative 1. Step 1, circle the negative 1. Step 2, determine whether it's open or closed. Well, since this one is greater than or equal to, then I make it closed. Okay, then I determine which way my arrow goes. Since x is greater than negative 1, greater than numbers are to the right. Or I could say, well, 0 is greater than negative 1, so it must go toward the 0. So I can draw my arrow toward the 0. And I'm done. I've graphed it. Alright, so the next one, it says 4 is greater than x. So I go circle my number, circle the 4. Since it can't be equal to, I don't color it in. I keep it open. Now, what about my arrow? Well, that's a greater than sign like this one was, so do you think I'd draw it to the right again? Well, I might if the x was the one that was greater than, but this time the 4 is greater than, which means x is less than 4, right? Okay, think of a solution that would work for this. 4 is greater than 0. So I have to draw my arrow toward where the 0 would be, which would be in that direction. So that's my graph for that one. And then on the last one, you can kind of see us putting it all together. We're going to solve this inequality and graph it. Okay, so we solve it by moving the plus 3 to the other side, so minus 3 on both sides. And we get x is less than or equal to negative 2. Okay, so now I'm going to graph it. Circle the negative 2. Do I make it open or closed? Oh, well, it has the equals to, so I'll make it closed. And then, since x is less than negative 2, then I draw my arrow to the left. Okay, also I could say that negative 4 is less than negative 2, so I draw my arrow toward the negative 4. And that's how we solve and graph inequalities. So you should be able to work on your practice now.